The second part of this lesson, lesson 9.4, is about using matrices to rotate our geometric figures. So here are the rotation matrices. Pause the video a moment, take time to write these down. Again, I probably won't put these on the test, but someday you might find them very handy. So go ahead and pause it for a moment and do that. Okay, so now if I'm going to actually rotate a figure 90 degrees and 270, first of all, I'm going to graph these. So here's my point R. S is 5, 5. T is 6, 1. And U is 0, 1. Okay. So there's my trapezoid, and I didn't do a great job of drawing it. And now if I want to rotate it, remember how we do this? We write the matrix with the X in the numerator, or in the top row, excuse me, and the Y in the bottom row. And now the 90-degree matrix is 0, -1, 1, 0. Okay, so I'm going to switch colors so we can see it. Now remember, you're going to take the individual numbers in this row times the individual numbers in the column. So we're going to have 0 plus -5. We're going to have 0 plus -5. We're going to have 0 plus -1 and 0 plus -1. Then I'm going to switch to the second row, and it's going to be 1 plus 0, 5 plus 0, 6 plus 0, 0 plus 0. So that matrix becomes -5, -5, -1, -1, and then it's 1, 5, 6, 0. So let's see what that graphs. -5, 1, -5, 5, -1, 6, and -1, 0. Do you see how that rotated it? It did exactly what it said it was going to do. Okay. Now I'm going to erase that, and we're going to rotate it 270. I'm going to leave that graph there. Okay. And now remember, these change too. We got to go back to the 270 matrix. It doesn't look a lot different. Okay, we'll use blue now. 0, 1, -1, 0. And again, I'm going to take the row times the column, the row number times the column. So I'm going to have, I don't want this marked yet because that's my workspace. Okay, 0 plus 5, 0 plus 5, 0 plus 1, 0 plus 1. Okay, then the next one is going to be -1 plus 0, -5 plus 0, -6 plus 0, 0 plus 0. So it turns out to be 5, 5, 1, 1, -1, -5, -6, 0. Okay, I should have compared before, but look what happened to the rows in our matrix. Take a look at what happened there. Okay, but let's graph that real quick. So we got 5, -1, 5, -5, 1, -6, 1, 0. And did not that rotate it? It sure did. Okay. So that's one way you can do that. You can also just realize what's happening to each ordered pair, but a matrix could be a handy way to do it. Okay. One last thing is the rotation theorem. Okay, it says a rotation is an isometry. Remember, isometry means a transformation that produces a congruent image. Okay, so when they are asking you to make use of this isometry, they want you to realize what goes with what. Okay, so because it's rotating, the 12 should go with the 2s. And then you could solve for s by dividing by 2. I know that looks like a 5, but it's supposed to be an s. Okay, what does 3r go with? Well, the 3R should go with the 2S plus 3. So 3R equals 2S plus 3, but S is 6. So this is 2 times 6 plus 3, so 15. So R is 5. So this would be 15. This would be 15. This, of course, is 12. But when we put 5 in for R, 20 minus 3 is 17. So you can use the things you know, a little bit of algebra, and be able to find measures of polygons.